Hello, thanks for joining us today for the Elastic Global Conference. I hope you're having a good time. My name is Imma Valls. I'm a senior support engineer here at Elastic. Welcome to this talk on how we approach troubleshooting an Elasticsearch cluster in our team. Let's get this started. Elastic support, we've been there in situations where Elasticsearch cluster is down or performance is highly degraded. Sometimes this happens out of the blue without users being aware of the reasons while we're trying to keep our cool. Things can escalate quite quickly at times, and we might have unhappy users or managers or the account teams looking over our shoulder. Or even worse, we have users taking to social media about our outage. How can we be ready to deal with this? Know what we do and how to work such an issue is key to keep calm. As an Elastic support engineer, part of our job is helping our customers navigate these kind of situations, advising on what tools and knowledge sources to turn to for help. After this talk, I hope you feel more confident when troubleshooting Elasticsearch, knowing what tools and resources you have at your service. And even better, maybe it helps you prevent future outages, who knows? So what's our approach to troubleshooting? How do we go about our everyday support job? I like making an analogy with an emergency room. Fortunately for everyone involved, this is not a life-threatening situation. However, in my opinion, still makes sense to compare the way we work at Elastic Support to how medical staff deals with emergencies. And this is how I see it in 4 steps. I'll zoom into the 4 steps, the triage one. In triage, we focus on identifying how life-threatening the situation is. Is the cluster completely down or unresponsive? Are we dealing with degraded performance affecting the customer's business? Those cases will be treated as urgent and will be work together with the customer 24/7 until stabilized. To do this triage, it's important to ask questions to help us assess how critical it is. We'll ask for the cluster health. Is it red? Is it yellow? Is it green? Similar to fever in a patient or other vital signs, it's the first sign of urgency. Symptoms, is the cluster unresponsive? Is the cluster up but critically impaired? Slow ingest, slow search, nodes leaving and rejoining the cluster, data loss. We'll also ask what happened when this started. Sometimes we oversee this, but there can be previous changes that led to the situation, from a patch at the OS level, Elasticsearch configuration changes, increases in request volumes, etc. Knowing this might guide us to the cause, but more importantly, can help us stabilize the patient faster. If it's something we can quickly revert or roll back, we might get to a better place sooner, and we can investigate the root cause with less pressure. Finally, did anyone already attempt anything to fix this? For example, were the nodes restarted? Any changes in cluster settings? Based on the triage, if we determine the situation is not urgent, we'll schedule a regular appointment. For Elastic support, that means we won't be working 24/7 to fix this, and that we can take some time to find the root cause during regular office hours. The support engineer that usually works with that customer, similar to their usual doctor, will have the whole picture and will be better able to help. We use the emergency room to stabilize your urgent cases. Triage is important. We need to keep room for incoming new emergencies. For sure, we'll also keep cases here that are non-critical at the moment, if we think that not fixing this will probably cause an urgent issue. We do not want to send a patient home and having to come back later with an emergency. If the issue is urgent, we'll proceed to the second step, the diagnostic. Similar to what doctors have, X-rays, blood tests, we also have several tools at our disposal. The ones we use the most are included here. The Elasticsearch REST APIs, we use a lot, and we have the support diagnostics utility that helps us gather all the relevant calls faster. We'll see this in a bit with a concrete example. We will usually gather the node logs, which can help us understand what's happening. And we also rely on monitoring data. The whole Elastic stack can be monitored, and this gives us the historic data that's very helpful. And with the necessary information from the diagnostic tools, we will search on GitHub public repos for known issues that can be related. We can also search on Stack Overflow, Elastic Discuss forums to look for similar issues and what other users did to solve them. Internally, we have our knowledge base of our customer cases, so we'll also search there. And of course, we can always Google it. We're not alone troubleshooting. We have an internal support Slack channel and a Zoom always on room where our colleagues are ready to lend a hand. We might need help from our developers, and for that, we can open a thread with them. We use internal GitHub repos for that, and we also use Slack channels. With all this information and help, we will make a diagnostic and propose a course of treatment. Treatments will usually be tactical, aim at stabilizing the situation. For example, we can decide that a cluster at full storage will stabilize adding nodes or deleting data. We can later think of how to fine-tune the ingest. It might require tuning index mappings, implementing index lifecycle management, or other actions that will take time and can be done under less pressure. If the treatment doesn't work, we'll go back to the diagnostic step. Maybe we solve one issue, but it was not enough to stabilize, or maybe nothing changed. We'll gather information again and keep analyzing until we succeed. Once the cluster is stable, we can suggest some best practices to prevent future occurrences, similar to when a doctor sends us home with some medicine or dietary recommendations. And we might also send the patient to a scheduled appointment for a follow-up to help prevent future occurrences. When dealing with urgent issues, we do not usually have time for root cause analysis. We need to clear the emergency room for other income emergencies. If the cluster is stable enough, we'll move on to other urgent patients and stop working 24/7 on this concrete case. This is the analogy I'll use in this presentation, and next I'll showcase this approach with a couple of examples taken from what we see at Elastic Support. We'll start by digging into a typical support case of a red cluster. Here we have an example of an urgent severity case. The customer has informed us that the cluster shows a red health status, and it's also not ingesting any data. The first thing we'll do is go through triage, even if the customer might have told us already what symptoms they see when opening the support case. We will still assess the severity and impact to get more context. Vital signs. The customer said the cluster is red and then there is no ingest. Using the Get Cluster Health API endpoint, you can see this is other interesting metrics. Active shards percent as number shows us that some shards are missing and unassigned shards is reporting 1. We will further inquire about symptoms. Is the cluster totally unresponsive, or does some operation still work and it's only the ingest? Are there any errors in the logs? So we'll also ask what will happen. The customer in this case has no more information that might help us. What they observe is that ingestion stopped out of the blue and the cluster became red more or less at the same time. Was anything attempted to fix this? The customer did not try to restart any nodes or change any cluster settings. What to do next? If the customer did not share support cluster diagnostics when opening the case, we will ask for it and the Elasticsearch log files covering the time span where the issue started. If the cluster is responsive to REST API calls, as was the case here, the support diagnostics utility will capture all the relevant information and bundle it in a zip file. And we'll be able to investigate why the cluster turned red and if the ingesting stopping is related to this event. In this presentation, we'll use the REST API calls, but have a look at the URLs provided here, which explain what information is bundled in the support diagnostics and where to find those API calls. It's a useful tool. Once we have a support diagnostics, or if we have access to the cluster to troubleshoot via screen sharing session with the customer, we can run a few API calls to figure out more. First and foremost is finding out why the cluster is red. Cluster health reflects the health of the worst index and the worst chart. So this means that we have at least one index with one chart and a sign. We can execute some of the CAT APIs. CAT is for compact and aligned text, which are more human readable than the APIs that return JSON output. First, we'll run the CAT indices API. Here with some parameters for readability, you can see. And we can see that there's only one index in red in this case. As we see no documents in the event log 7 index, we'll dig into it a bit more. We'll check all the shards sorting on state descending. We will see if one or more shards from different indices are not allocated and what their status is. Primary shards in state unassigned would cause a red cluster. And we can see this is indeed the case here. The index event log 7 has one primary shard which is not allocated. If it was a replica, we would see a yellow status. Though being a primary, we do not have data for that index, at all, and the index will therefore be read. So why is the shard not allocated? We can use the allocation explain API to get more information about the index and specific shard that is unassigned. And we get more information than from the health API here. This seems related to the fact that the node where this shard should be has reached its highest watermark. And what is this? Elasticsearch uses this base shard allocator to ensure that all the nodes have enough disk space. It allocates shards based on two thresholds, the low watermark and the high watermark. It will ensure that that no node exceeds the high watermark, or at least only temporarily. If a node exceeds the high watermark, then the Elasticsearch cluster will solve this by moving some of its shards onto other nodes in the cluster. If there is no space left on any other nodes, shards will be allocated. Will not be allocated. But why did Elasticsearch stop ingesting completely, apart from changing its health to red? We can understand that when index 7 block 7 was first created, there was no space left on the nodes and it was not allocated. And that is why we cannot write on that particular index. But the cluster sees that they cannot ingest, but the customer is seeing that they cannot ingest into any other indices either, the ones that had already been created before this red step. To understand that, we can use the cat allocation API to check how much storage we are using. We see that the remaining disk space is very low. In this small cluster, it's just one node with 21 gig of storage that I used for this presentation. We have less than 5% available. We're using 96% of our storage. If we have a look at the cluster settings, we'll notice the default disk allocation values. If we go above 95% of the disk usage, the cluster will become read-only to protect itself. Not only will it not assign new shards, like it did for event block 7, which had the unassigned primary shard, but it will also block writing on existing indices, thus stopping all the ingest, which is what the customer was seeing, because they are 96% disk usage. If we had not reached the flood stage, just the high stage, 90%, we'd have a red cluster because of the unassigned shard, but we would still see ingest happening until we reach the 95%. And this is why attempting to write to any existing indices will fail. We can only execute read and delete requests on those indices. That's why also the cluster is responsive, but we cannot write. Therefore, the search will still work, as we said, for this customer, but not the ingestion. Even if we try writing on an index that is not in a red state, the cluster setting blocks this. Now that we know what happened, it's time to fix it. The quickest way is to increase the available disk. We can add nodes or alternatively delete older data, reducing the data retention. If we have snapshots, we can always restore those indices later if needed, once the storage issue is solved, or we can reingest the data later from the source if we have it. Technically, we also change the disk watermarks, which can be percentages or absolute values, though it's not the recommended path. This can allow us to have higher disk usage, but we need to take caution. We can change the settings using the transient section of the cluster settings while we figure out what to delete, or if we should add capacity to the cluster, but with caution. We do not recommend this usually. Once we recover enough storage space, in the most recent versions, we will see the indices block is automatically released after 30 seconds as a default, though we might need to manually fix the indices that were in read-only if we're working with older Elasticsearch versions. Here we present a quick bonus trick, which is a bit more advanced. In case the reason why the cluster was read is due to shards that were corrupted, which is not the case in this example, or if we only have a stale shard, not an ideal situation either, we can manually force the cluster to allocate those indices using allocate stale primary or allocate empty primary. We are accepting data loss, but it can help us to partially recover data in some cases where there were no snapshots available, and some of the shards were not recoverable. Finally, we have some recommendations and best practices to send the patient home. Make sure you have alerts in place for nodes, node storage usage. We recommend to keep the nodes at around 75% disk usage so that there is room for growth until the 85%. below this watermark. For high storage nodes, sometimes we use fixed values, not percentages, but it's up to you. Use tools like ILM to make sure all their data is deleted. Or alternatively, with data tiers, in the cold tier, we can remove replicas on the nodes while using a snapshot as a replica. In the frozen tier, we will use even less storage. So those are also mechanisms we can use to reduce the storage. Also remember general best practice, use SLM, the snapshot lifecycle management, to make sure you have your data backed up in case you need to delete data temporarily to make room or to recover from any data corruption or loss. And this is a summary of what we discussed for future reference, the symptoms, what we use to reach a diagnostic of the situation, how we can fix it, and what we would recommend to prevent this in the future. Next, we'll review the process with another example. We sometimes see an Elasticsearch cluster showing how CPU usage, but only on one or a few nodes. This would not qualify as the first example for an urgent severity, but it's still high severity. So we'll keep this case in the emergency room. We need to figure out what is happening, as this unbalanced high CPU usage is suspicious and could cause issues in the future if not treated. The symptoms for the customer are that the cluster is healthy, it's green state, but they keep getting high CPU alerts in the stack monitoring. What we see here is our monitoring graph. In our monitoring graph is that for this concrete time range, the last 15 minutes, instance 2 has higher CPU usage than the rest. It's over 90%, while the other two nodes are at 10% or even below 1%. The customer has a cluster with just 3 nodes in the example, and those alerts keep switching in time to different nodes. It's not always the same. And while one is in high CPU, the other two seem very idle. And they report that ingest is a bit slower than what they would require. So if they were using the CPU of the other two nodes, the ingest would probably catch up for them. We usually ask the customer if they did any benchmarking before going into production, and if they noticed that already, and balance CPU usage. If they did not, we'll ask if this is something that appeared out of nowhere, and if they have recently seen any increase in the volume of data being ingested, for example. The more we know about the situation, the better. In this example, the customer tried adding nodes and saw no changes. Still one of the nodes with high CPU usage, and the others were idle enough, while the ingest rate remained the same. So that did not help, and they reverted back to 3 nodes. What our ask from Elastic support will be is that they explore monitoring data. This is a very useful tool in this kind of cases. It will allow us to dig into the history of how the cluster is behaving, what is happening in the cluster when one node is in high CPU, when it switches to another. And we will ask for support diagnostics also. Even if this is a snapshot in time and might not explain the CPU switching, it helps us understand the cluster configurations. Elasticsearch has its own monitoring tool that comes in very handy when troubleshooting these cases. So this is the main tool we would use to start investigating. With the APIs, we get current values, snapshot of one modem, but we're missing the historic data. A combination of both will do the trick here. Looking at monitoring data for this customer, selecting a time range where one of the instances shows high CPU usage, we find that there is one index logs to a 1998 that has a much higher ingest rate than the others. It's what we would call a hot index. And at that particular time, instance 1 was the one with high CPU usage. We then resort to the REST APIs to check how many primary shards this index has. And we can see that it's only one primary shard and it lives in the instance number 1. So it makes sense that the most CPU usage we see is on instance 1 during the time when the ingest rate is high for this index. We would confirm selecting another time range where a different index has high CPU and see if there was a hot index on the node that had the high CPU at the time. We could also check online while this is happening to confirm our suspicions. If we execute the hotflex API, we can see that instance 1 is busy writing, it's using a lot of CPU, and that can help confirm. In this case, the customer has one hot index doing most of the ingest, and when they create a new hot index, it can be assigned to a different node in the cluster, and then they see the high CPU usage switch to that node. Now that we know what is going on, how to fix this? how to make sure that we make use of the CPU available on the 3 nodes instead of 1. We can configure that index to have 3 primary shards, so the load is spread. We would adjust our templates to make sure the hot index, if we are using rollover, is created with the right settings. Now with the right number of primary shards in the hot index, we would see that the CPU usage is spread on all the nodes. So far, we discussed a small cluster with a single hot index to make an easy to understand example. In reality, we might have 100 nodes cluster with what we know are, let's say, 1 or a few hot indices and lots of not so hot ones. Elasticsearch just balances in number of indices per node. It does not take into account what indices, if they have high ingest rates or not. If we configure the hot indices to have 100 primary shards, there is nothing that would prevent those shards to fall on just a few nodes instead of 1 on each node. That's creating, again, probably some CPU hotspots. For that, we can define at index level that we don't want more than 2 or 3 shards for those indices to fall on the same node. For example, in this way, we make sure that the load will spread. We do that for the hot indices, but do this with caution, as this is a hard limit and might lead to unassigned shards if we set it to a very low value, because some nodes might leave the cluster, and then we don't have nodes to allocate those shards. What can we learn from this? We should monitor our CPU usage and configure alerts to make sure we detect unexpected resource usage spikes. And we can always use Elasticsearch Rally to fine-tune the cluster for our concrete case before going into production. We can create our own load testing scenarios with custom tracks and check that our shard configuration, mappings, etc., is correct for our needs on our platform and fine-tune it. It will also help with capacity planning, for example. How many nodes do I need? And this is again a quick summary of the process. The tool we found most helpful here was monitoring, and it allowed us to review what the customer was seeing, CPU usage changing, and what was happening in terms of ingest rate at those times. As a conclusion to this talk, which I hope was useful to you, a quick reminder to simply remember the emergency room analogy. Triage your incidents. How critical is it? Do we need urgent care, or can it wait? Have your tools ready. Monitoring, alerts, log analysis, use Kibana for that. REST APIs. And do not forget search. We did not discuss it in this talk, but as support engineers, we will need to be experts on search too. Find existing bugs, and when they were fixed, if it were, looking at similar issues that other users had can inspire us or directly offer a solution or workaround. Once fixed, learn from the incident and apply best practices. Even better, put best practices in place first to prevent those issues altogether. In our documentation, we have useful guides we often send to our customers, like how to tune for ingest speed, search speed. We also add to the docs troubleshooting guides that I find particularly useful, not just when troubleshooting, but to prevent some issues in the first place. So I usually go and read them even before I start anything. You'll also find plenty of engineering blogs that are very interesting, from how to use ILM or data tiers to how we can tune bits in just performance. There's a lot of useful resources out there. Thanks very much for your attention. I'll be around in the chat if you have questions. Enjoy the rest of the conference.